the last time we met with parents, we started talking about what we were going to do with fractions and what students were responsible for learning, and we started talking about things like what are unit fractions, what are the roles of the numerator and denominator, and that's the first thing we did with kids, was really do foundational things, how do fractions work, what part of fractions do what, and so that they can carry that forward when they get into algebra and higher. And then we had to get into specifics of 5th grade fractions. So a lot of that, we add and subtract, of course. We multiply and we divide in a limited way. So I think I'm going to start today just by showing you what the kids did when we introduced adding and subtracting fractions, because that might be the hardest thing we do. Maybe the hardest thing to do computationally. The hardest one to understand is probably multiplication and division. So I'll just take you through this, and I should have put my clicker in, but I didn't. Okay, so we started out kind of silly, 4 dogs plus 2 dogs. And if you want to turn that off, I will get the clicker because that'll be faster. 6 dogs. I'll be right back.
Hey, Jonathan, can I pause?
Okay.
You can stop the video, then start a video, then edit them together using iMovie.
Is that okay? I'm sorry. Okay. Okay. So we talked about, when you're putting things together that are the same, it's easy to put them together. You just count how many you have, and here you have 4 dogs and 2 more dogs, and that gives you 6 dogs. And then we went to actually using fraction words, but actually writing it out in words to remind you that the number 7th, that is usually the denominator, is actually the name of the fractional part. So 4 sevenths and 2 sevenths, and the kids were, oh, that's 6 sevenths. So that makes sense. I mean, we're counting sevenths, and we have 4 and we have 2, and you put them together and get 6, just like the dogs. And then we showed it in fractional form so they can see that this 4 sevenths is this 4 sevenths, and this is just the symbolic representation. And 4 sevenths is 4 groups of 4 sets of 1/7, and 2 sevenths is 2 1/7, just to show us that all fractions are made up of units. And we'll go with that. But then we said, well, what happens when you're adding 3 dogs and 2 cats? You get 5 of something, but we're not sure what to call that something. And so we were like, is that 5 dog cats? And it was kind of silly, and we laughed about it. And then we talked about why is that hard to understand, because we are adding things that are not the same. And there's no common name, or there's no name that we can call the 5 things unless we think of a common name for dogs and cats. So the students actually did come up with pets, and some of them said animals. So we're like, okay, so there's a common name now, and now we can add them together. Did it again with trucks, cars, and motorcycles. Does that give us 9 truck carcels? No. That doesn't even make sense. So we were like, well, what would a word be that we could use to add trucks, cars, and motorcycles and know that it's 9 of something? And students did come up with calling them vehicles. So we come up with, that's 9 vehicles. Now you have a common name. So we wanted to take it as, this is our geometry review. Squares, rectangles, and rhombuses, we did 13 of something, and it's 13 parallelograms, so that gave them a chance to review what would be a word that would work for all 3 of those shapes, all 3 of those polygons. So this is geometry review. Now we went deeper because it's not only finding a common name, it's finding a common value. So what we talked about here is 1 bill plus 1 bill is 2 bills. If I have 2 bills in my pocket, 1 bill over here, 1 bill over here, I pull it out, I've got 2 bills. And then I showed them this picture. And that kind of, when the class got quiet and they were like, wait a minute, something's not right. So they have the same name, they're both bills. And I said, what's the problem? If this is a bill and this is a bill, don't we have 2 bills? That's a common name. And they all kind of caught on to the fact that the problem is the value. We don't really know what we have because the value of them are different even though they have a common name. So we went back. So in the last slide you had this and this. If you, instead of calling them bills, called them dollars, would that help? So we were like, yeah, dollars tells you that you have $10 and $1, and now instead of 2 of something, it's actually 11. So it actually is a word that not only has the same name, but shows the same value. So I'm speeding this up a lot. This was like almost the whole class period that we worked through this. So when we renamed the objects, we changed the number of items to reflect the real value in the new name. The $10 bill is actually $10. instead of 1 bill. Okay, so while 1 plus 1 is 2, and 1 bill plus 1 bill is 2 bills, it doesn't show the value like the word dollars would, because $10 plus $1 is now $11. So now we start talking about fractions. And we talked about if you have the following fractions are from the same whole, because in the last class we talked about how everything relates back to the whole. You have to know what your whole is to know the size of a fraction. And we had a joke about pizza from 2 different pizzas. And, but here, so I'm letting them know that this is the same size whole. So now you have 2/3 and you have 4/5. And the common thing is to say we have 6/8. That's what students usually do before they're more sophisticated about fractions. But really, does that show the value of what you have? Because we should know that thirds are bigger than fifths, and we work on that comparative size. It doesn't give us 6 3/5. There's no such thing as a 3/5, really, and it doesn't help us understand the value of the sum. So then we start talking about, let's estimate. 2/3 is more than half, and 4/5 is close to a whole. So shouldn't your answer when you put them together be about 1.5? And that's what we do a lot of with estimating addition. So if you added and got 6/8, it can't be 6/8 because 6/8 is less than a whole. So this is the kind of reasoning I want students to do. Is not only just what usually happens is students find a way to do something and they just do it and move on without making sense of it. And we're really pushing, and I would like for you to push, that we make sense of everything. So if we know this is almost 1 and this is more than a half, there's no way we're going to get less than 1 when we add them together. And that would hopefully stop them from doing the wrong procedure. So we talked about what can we do, and we have a picture. So we like to go back and do area models is a really good way to model this, but have a picture so that they can actually visualize what does 2/3 mean. So you have a whole here, there's 2 parts shaded, it's divided into 3 equal parts, and then 4/5 you can see 4 of the 5 parts that make the whole are shaded. So they're different size parts, as you can see. I mean, it almost looks like I could split that in half and maybe lay it over here, but it would probably come out a little further, so they're not the same thing. So I repeated it again, but this time I'm going to do something a little magical. I'm saying, how can we make these parts the same size as these parts? And I showed them this. So they looked at it for a while and thought about it, and what I want them to see is that I took these parts and laid them over this. And I took these parts and laid them over this. And now I have 5, 10, 15, 5, 10, 15 parts in the whole. They're all 15ths. They're all the same size. We can actually put these together now. So we're showing a couple of things here. We're showing equivalent fractions, which they had already worked on, but we're also showing you need equivalent fractions with the same size part. And now you can see that 2/3 equals 10/15, and that 4/5 equals 12/15, and now you could put them together. So we kind of went back and forth, taking the parts off and then re-showing it so they could see what was happening. And then the explanation. So if 2/3 equals 10/15 and 4/5 equals 12/15, we can actually put these together because we have the same size part, and we know what to call them. They have the same value, and we have 22 of them. And 22 we broke apart into 15 and 7, 15 being 1 whole, and 7/15 left over. So this makes more sense because this is almost 1.5, which is what our prediction was, so our estimate. So that was kind of how we introduced finding common denominators, the reason for it, why it helps, how we can add and compare and subtract using fractions with common size, part sizes. We then connected it to decimal, and I won't go too deeply in that, but basically we talked about how we line up decimal numbers to add, because we want to add the same size parts together. It's the same idea. And then I won't take you through that, but that was an introduction to adding and subtracting with fractions. See what I want to go, so any questions so far? Okay. Then we went into how do you get common denominators, and I'm going to take you out real fast. It took us days to do this, but pull up the screen. We basically talked about 3 different methods, and I'm sure you'll be familiar with them. We do not do factorization for getting a lowest common denominator or greatest common factor in 5th grade. but we start to think about it and sometimes hit on it near the end of the year. But basically I taught them 3 methods, and the first method is the cross method, which most of the students can do pretty easily. The problem with it is making sure they understand that we are not multiplying fractions because we're multiplying fractions. We are multiplying to get an equivalent fraction so that we can add. And I sort of taught it to them as this is a step so that you can do something. Just like, I'm not going to think of a good analogy right now, but you know, if you've got a big game that you're preparing for, you practice so that you can play well in the game. It's not that you're playing the game when you're practicing. So the cross method is just basically if you take 2 fractions that have different size parts, and one way to get a common size part, a common denominator, is to have a common multiple. Common denominators are usually common multiples. Could be quotients, but we won't do that. But common multiples of both the divisors. So the easiest way to make sure it's a common multiple is to multiply them. And then they're both factors of whatever you get. So this part is multiplying 4 times 3 and you get 12. Okay? And 3 times 4 is 12. Okay? The cross part is just forcing you to get the numerator you would get if you have the same denominator. So 4 times 3 is 12. To get an equivalent fraction, and we had already worked with equivalents, you have to change the 2 proportionally. And you do proportional change through multiplication and division. So if you multiply 4 times 3, you also have to multiply 4 times 2. And the direction is important. 4 times 2 is 8. Okay? So 2/3 equals 8/12. And then if you do 3 times 4 is 12, you also have to do 3 times 3 to get 9. So what I taught the students is once they have done this, I want them to rewrite the fraction right below its equivalent to keep them in the same order. Because it won't matter in addition, but it will matter in subtraction. If you'll notice, they can also compare now to see which fraction is bigger, because this has more parts of the same size than this one. So 3/4 is bigger than 2/3. Now that they have this, they can add, and most of the students knew I'm not going to add the 12 because that's the size of the part. That's the part I have. This is how many I have. And we get 17/12. So that was the first method they learned, and they really liked it and were really effective in using it. But it's not always the best method.
Had you already talked about proportionality of fractions?
Yes, we did it with, we started talking about proportionality earlier in the year when we were moving decimals, and talked about multiplying and dividing by 10 to change numbers. But basically the way I teach proportionality, if you want to talk to your child about it, is if something's proportional, they relate to each other in the same way. So this right now is half, the green is half of the red, okay? Now if I change the red and multiply it by 2, it's going to be this. Well, now this is not proportional. It's not the same relationship because now 4 of these fit. So I'm going to have to multiply this by 2 as well. And now they are exactly the same relationship. So you go back again, and then I go, well, what if I want to multiply this by 4? And I just show the students, remember I'm multiplying. Now it's 4 times bigger. How can I make this relate in the same way? Make it 4 times bigger. And now it's still half. So we talk about proportionality is achieved through multiplication and division, but not adding and subtracting. And you know, if you put one little piece on the end of this and made it bigger, it wouldn't fit the same way. So it has to be through multiplication. And that was kind of a basis. So when we did this, hopefully it was just kind of a natural. Remember when we did this with decimals? Well, it's the same now. And we did one day with calculators where every table multiplied numbers by different numbers, and then divided, and they saw that they all got the same answer. So they were like, whoa, this is actually the same thing, even though we changed the numbers. I said, yeah, but you changed them proportionally. So that was kind of what led into this. So I use that word constantly, make proportional change. Instead of saying whatever you do to the denominator, do to the numerator. I don't think that's very mathematical. So I say if you change the denominator in a certain way, you need to change the numerator proportionally to get the same amount, so that they will remember that you are multiplying both by the same number. So the second method I taught was listing multiples. And this is how you would get the lowest common denominator. But I also told them this works the best when you have 3 fractions. So let's say you have 1/2, 2/3, 3/4. And we try not to use really big numbers because it doesn't make you better at it, really. It's just to get the concept, I try to keep it simple. I usually don't go over tenths, just because I don't want huge numbers. I want them to understand. So if you're, and I've really been driving home, if you know your multiplication facts, you can probably go ahead and tell me a common multiple of 2, 3, and 4. If you don't, let's list them. And I usually ask them to start with the highest number. So listing multiples is count bys, if you want to call it that. So 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. And I usually tell them you might need to go out 3 to 5 numbers or something. And then let's go to our 3. 1 times 3 is 3, 6, 9, 12. Okay, at this point you have a common multiple, 12. And you could list 2's, or you could just say to yourself, is 2 a factor of 12? If it is, use 12, okay? So again, I put the numbers right below the fraction that they're going to be equivalent to. And we talk about what multiplier did you use to get from 4 to 12? 4 times what equals 12? And it's times 3. And then I say, how do you proportionally change 3/4 so that it's going to be equivalent? And that is to multiply the numerator by 3 as well. So we get 9/12. And I'm really pushing the children to write this so they don't forget to do it. They're extremely stubborn and don't like to do it. But I would really encourage that you need to do the work and see it visually, so because we do forget to do things that we don't see. Right? So 3 times 4 is 12. How do you proportionally change it? 2 times 4. You can get 8, and then 2 times 6. And by this time, they're kind of flowing through it. Now, again, you have common denominators, and it's just a matter of putting together the number of parts that you have, 6 plus 8 plus 9. Students still have a really hard time with 3 fractions and get a little stuck. A lot of them want to use this method with 3, and it's just not very effective. And if they did 2 times 3 is 6, and 6 times 4 is 24. With these fractions, it's okay, but I've seen students get 96 as their common denominator because they're wanting to multiply everything. And they get the right answer, but it's not as efficient. The last method I call use what you got. That might not be good grammar, but it's just kind of my funny name for it. So let's say you have 2 tenths and 3/5. And I tell them, if you're really thinking about multiplication and multiplication facts, if you look at, just take a second to investigate. It wouldn't have worked here because 3 is not a factor of 4, but if you look at 10 and 5, always look at the highest number. Is that a multiple of the lower number? And yeah, 5 times 2 is 10. So let's just use what you got. Let's use 10. And that way you don't have to change. And we're going to make this into tenths. So we're going to proportionally change and get 6 tenths. And that's fast when you have already have a common multiple as one of the denominators. Now most students will still do 10 times 5 and get 50, and that's fine. That's fine. I just tell them you're working with bigger numbers and it's harder to understand your answer. So go from that. We have done simplifying. It's not required in 5th grade to simplify, but I want them to start doing it so that they understand when they get to middle school and they're required to do it. As far as the EOG, if they put, what am I thinking here?
8 tenths.
Yeah, I mean 8 tenths would be right, but also 40/50ths would be right. They don't have to simplify to get the to get credit for the answer. It used to be that way, and thank goodness it's not now, because an answer is an answer is an answer. They're equal, so why should it be wrong? And I've told them that simplifying is just a way to get an easier to understand or visualize fraction. Because if you tell me picture 50 pieces and what would 40 of those look like, that's really hard for me. But if you say, picture 5 pieces, what would 4 look like? I'm going, oh, I see that. So it's just simpler to think about.
And then do you ever talk about the fact that 2 divided by 2 is 1, and that's an identity?
That's the next part.
Oh, okay.
We did talk about that. And I didn't introduce that until the very end of doing equivalence. We had an equivalence day where we did lots of different activities with equivalence. We were simplifying. We were turning improper fractions into mixed numbers and vice versa. We were finding missing numbers in equivalent fractions, and we were working with the equibeam. This was kind of fun. I just marked the equibeam in fractional parts. So on this one we had fourths and eighths, so they could place and find out how many fourths would equal this many eighths. This one had halves, thirds, fourths, and sixths, and we had to turn them into twelfths. So that was just a way to show equivalence by balancing the parts. We did fraction quilts. We did so much that day, but it all came down at the end when we kind of debriefed about what we were doing. We talked about why does this proportional change end up equaling the same amount? And I kind of let them look at it for a while. And as we sat there, and there was kind of crickets chirping for a while, and then I just kind of would walk over and just go, and all of a sudden, some people started to say, and what I wanted them to see was this. They are multiplying times a fraction, but that fraction is equal to 1. So we go back to the identity property, which we've talked about all year. Anything times 1 gives you an equivalent amount or the same amount. It doesn't change anything, it keeps the same identity. And I teach that with the picture of the mirror. We're having a hard time still remembering the name of that. They've got commutative property down, but identity property, I have to pull it out of them still. But basically the identity property, adding 0 or multiplying by 1 does not change the identity of the other number. So, we talked about also, when you're simplifying, you're dividing by 1. Still, it doesn't change the value. Yeah, I'm glad you brought that up because we did talk about that. And I introduced that really earlier in past years, and this year I waited till the very end because I didn't want that to stop them from thinking about what they were doing proportionally. And then once they got this, they were like, that makes perfect sense, what we've been doing all this time. So I'm doing things in a little bit different order this year to try to hold off on letting people know things for a little bit longer, which is hard. Let's see. So yeah, I've got that down. Equivalence, identity, property, proportional change. Okay. We did mixed and improper fractions, and I think we may have talked about this last class, how we did it. Did we? Do you remember? I don't remember. 2 and 1/8. Let's just start with that. Mixed number because you have a whole number and a fractional part left over. And we talked about how do you make that into an improper fraction so the whole value is just in a fraction. So we looked at the whole. The whole here is 2. That means we have 2 wholes that are made out of 8ths. So the question to the students is how do you get 1 whole? If you have 8 parts in a whole, how many parts do you need to make the whole? And sometimes I'll draw it out and so that they can visually see you need all 8 parts. So that equals 1. And that goes back to what we just did with the identity. That equals 1, but I need 2 of them. So I'm going to write it again. And that is those 2, and we have 1/8 left over. So how do we make this into an improper fraction? We have common denominators, so we just add 16 17/8. Okay. We did this for a couple of weeks, and we had equivalence day. And on equivalence day, I finally taught them the shortcut because we had been doing this for a while. And I said, remember those 8/8 that were the 2? Here's the reasoning behind the shortcut. If you have 8 as a denominator, to be a whole, you have to have 8 as the numerator. So this is actually representing this. And you multiply it. So 8 times 2 is 16, and that's that. Plus 1 is that. So it's a sort of a magical little circle that they love to do once they learn how to do it, but I want them to keep remembering what they're actually doing. That's really hard because once they learn this, they don't want to do this anymore. So we do go back and re-explain it every once in a while. And then we took the way we were doing the improper fraction to a mixed number. Once again, breaking apart what's inside 17/8. There's some holes hiding in there. Well, the whole would be 8/8. Can we keep going? And they would go, yeah, you need another 8/8. We go, okay, how many 8s do I have now? 16. Can I do another 8/8? No. But you do have 1/8 left over. And then we would go, there's 1, and 1/8, so that's 2 and 1/8. So that was breaking it down into decomposing. And then when we were doing equivalence day, I showed them that it's no surprise. We've always talked about the fraction as a representation of division, so this means 17 divided by 8. So you could actually put it in the box and divide. And 2 times 8 is 16. You have 1 left over, and that's 1 of the 8 parts you need to make the next whole. So that's how you would convert it back into a mixed number. A lot of the students can do this in their head, but I remind them that they can actually do a division box and work it out. That helps. So we did that. and practice that a good deal. See. Then we got to multiplication. Multiplying. Multiplying is probably the easiest computational thing to do with fractions, but it's really hard to understand when to multiply with fractions. So, and the hardest thing that students have every single year is understanding that to count a fractional part of something is multiplying. Because as soon as they see fractional part, they think that's division or that's subtraction or something other than multiplying. So let me show you the sheet that we worked on. I don't know if this will help you if you want to take a picture of that. So the students just worked through a lot of things, and mostly word problems, and then I had them do it in pictures, so I'll show you that in a minute. So I have 15 crayons. 2/5 of them are red. So how many crayons are red? So right now on this paper, I never told them we were multiplying. I just said, just figure it out. So what is 2/5 of 15? And then this next one, 7 oranges are in my grocery bag. Each orange weighs 6/7 of a pound. Most of them saw that this is repeated addition, so they just wrote 6/7 down 7 times. 20 students in our class, 3/4 went out for recess, 1/4 chose to stay inside. How many are outside, how many are inside? This one was a little bit harder for them, they needed help. But this was where I really wanted to focus. So I'm going to do a couple on the board that we did. With I have 15 crayons. And 2/5 are red. Goes back to this thinking, and I'll go back over here to this board. When we first started working with fractions, we talked about how a denominator is the divisor of the whole. So if you have one whole, if this was 1, and this was the divisor, we would break it into 5 equal groups. And each of those groups would be one thing called a fifth. This is way back to foundational. What does 3/5 mean? The numerator is the multiplier of the unit. The unit's 1/5, so it's this, this, and this. You get 3 of these things called fifths, and that's what 3/5 is. So we kind of applied that reasoning to this. So actually, when students were stuck, I would say, well, draw something to represent crayons. It doesn't matter what they look like. Okay, so there's your 15 crayons. And then I would say, okay, how are we going to show what we want to know? We're counting fifths. What does the fifth mean? And they would go, oh, divide by 5. Because we had talked about the denominator being the divisor. So I would go, what is 15 divided by 5? 3. And so I'd go, okay, let's see if that gives us equal groups. Okay, so now you have equal groups, and this is different thinking because, well, I'll share something with you in a second. Now it says how many of those groups, or how many units are red? 2 of them. So the answer is 6. So we weren't multiplying. They didn't know we were multiplying. They were just figuring it out. So we did that page. The same thing with 20 students for 3/4. By the time they got to that one, if you had 20 students and 3/4 went outside, they said divide 20 by 4. And there's 5 students in each group, and if you had 3 groups, that's 3 times 5 is 15. So 3/4 of 20 would be 15. And we started doing this. 3/4 of 20. What's 2/5 of 15? That's what we're trying to find out. And so we started using this language a little bit. Let me get to, and then they had the one with the oranges. If you had 7 bags and each of them were 6/7, they knew, oh, that's 6/7, 6/7, 6/7. This got a little tedious, right? 1, 2, 3, 4, 5, 6, 7. Okay, and they were drawing oranges, so they were labeling their oranges. And they would get the answer, oh, well, that's 6, and they would start adding the 6's together, and they would get 42. And it's 42, things called 7. So it was funny because when we got to this point, one student in almost every block would say, wait a minute, this is repeated addition. Are we multiplying? And I would go, well, what do you think? And we would talk about that, and they were like, well, yeah, because if multiplying is repeating something, the same thing a certain number of times, and that's it. So it sounds simple. So it sounds like, yay, we got it now. We're good. And no, we're not. So let's go to the next one. This one I didn't have a word problem with, so it was more abstract. But the next one said, what is 2/3 of 6? And what is 6 of 2/3? Which one do you think's harder?
The bottom.
Here's how I did that. The students got stuck on that. And so I had them come up to the carpet and I was like, okay, because they were like, how do you get 6 of 2/3? I'm like, I don't know. Let's put this out. So I just put a bunch of these out on the carpet. And the student who asked it, who was just completely confused by that, I said, hey, come here a second. And they were like, what? And I said, can you give me 6 of those? And so they picked them up. Yeah, oh God, that's easy. Ms. Zeugner, why are you having me do this? Did I get 6? Okay, so when they walked over and handed me this, and I said, okay, so you gave me 6 of these. What are these? And then we turned them over. They're 6 2/3, 6 of 2/3. 6 of these is 6 of 2/3. So I'm trying to link the language, and once they did that, they were like, oh my gosh, you're just gonna add them together. So that's this. They saw that 6 of 2/3 was 2/3 6 times. Whoops. And then they would add and get the answer. Repeated addition, there's something about this, we're multiplying. Okay, 2/3 of 6. This went back to the, hey, let's draw 6 things. And then they would stand back and look at them, and it depended how they drew it. I saw this where they would say, oh, I see 3 equal groups. And this is 2 of them, so the answer is 4. Or they would draw like this and go, oh, there's 3 equal groups. So it was different. Everybody saw it a little differently, but it always came down to there's one group, there's one group. 2/3 of 6 is this. 6 of 2/3 is this. 2, 4, 6, 8, 10, 12 thirds equals 4. So really what I wanted them to see that both of these were equal to the same thing. And so the question was, if both of these were equal, no matter what direction we went in, what is that? And commutative property. So once I said, okay, so what's commutative? And they were like, addition and multiplication. So this has to be addition or multiplication we're doing. We're not subtracting, we're not dividing. What are we doing? So that was sort of this year how I tried to get to what does it mean to have a fraction of something, or something of a fraction, or a fraction of a fraction. That if you're finding a number of things, if I told you to get 3 of those, you're multiplying times 3. But for some reason, when you tell a student to get 1/3 of those, they stop thinking it's multiplication. And so that's what we've really been working on, the language of multiplication. And then we showed that multiplication was the only thing that gave us the answer that our eyes proved to us. So that's sort of where we've been with that. I didn't really talk about this being multiplication that strongly the first day. I wanted them to see it visually, but they were seeing it themselves. This really is multiplying, and it does work to multiply to get this answer. So let's see, where do we go from there? From there, we went a little more abstract and started talking about the types of problems that require you to multiply. I don't know if I've showed y'all this before. Can't remember. But this is something students got the. This one's not as good as this one. That was one I had to copy for a student that lost theirs. This is in their binder, and this is one of my foundational charts. And what I did was try to separate the 4 operations and say, what are the situations that would ask you to use a certain operation, not what's a keyword or anything like that, but what is actually happening in the problem. And this is always the hardest one every year, when you want to find a fractional part of another quantity, which is 2/3 of 6 or 2/3 of 1/8 or whatever, that it's multiplication, because most students want to subtract. So we go back through and say, well, what situations ask you to subtract? When you're trying to find out what's left, when you're comparing 2 to see what the difference is, when you're finding the distance between 2 numbers, has nothing to do with finding 2/3 of something. So I'm trying to really pull them away and make them be real specific about why they're using an operation. The only one we haven't gotten to yet then is the measurement, because we'll do that toward the end of the year. But repeatedly adding when somebody has x times as much of something as someone else, when you know length and width and want to find area, a fractional part of another quantity, or changing a recipe to make more or less of something. that we use multiplication. And hopefully this will carry them through for many years of the situations and word problems. This is in their binder, hopefully. Now, when I asked them to take it out the other day, some people had lost this, so I really want to urge. This is in a plastic sleeve. I bought plastic sleeves and put this in it along with our base 10 place value chart. They also have one with multiplication and division samples, and they have one to keep all their study guides. That's what should be in your child's binder along with vocabulary and other things. So we started using that and actually applying them to word problems and trying out different word problems and seeing what the situation was that matched. But even after you go through all of that, students don't believe when they see a problem to ask them to find a part of something else. For example, on our test today, or I'll go back to the study guide. The study guide, I am at work for 5/12 of a day. I am with students for 4/5 of that time. So we've talked about pronouns. 4/5 of what time? The 5/12. So I don't know if you want to take a picture of that, but this was on their study guide. So 4/5 of that time, which was 5/12 of a day, is 4/5 of 5/12. And this is the kind of problem that most students will want to subtract on. And so we keep talking about, I am trying to find a part of another quantity. So, and we're kind of getting there. It is multiplication. And also sense making. When they subtract, they don't get an answer that makes sense. So we're working on this. It's a very slow process. I will say I'm a little frustrated with the fact that we do these study guides, and I tell them exactly what they need to know for the test. You are going to be asked this, and this is the answer, and the next day they cannot produce it. I've had students who are telling me, oh, well, I never looked at it again. I'm not studying. And that's really not the habits we want to form. So I'm trying to teach them that when you do a unit, there are certain really main points that you need to understand, and that's what my study guides are. So I really encourage that you tell your student to spend time with their study guide, not just read it once, but to maybe read it and look up and be able to repeat what they just said, or to apply it by doing the work, doing the problems. This one, unfortunately, I had to be out this week, so this was the study guide, but I gave a self-correct and lots of directions for them to fill it out. And when I came back the next day, I had a lot of students who hadn't done it, so that was a little bit frustrating too, but we're getting there. We'll keep trying. So now's the fun part, and good, they left. Our next thing, we're going to do multiplying mixed numbers. Do you have any questions right now? Okay. We're going to multiply mixed numbers next, and from looking at the pre-test today, most students are going to do this. And there's a reason they're going to do it, because they did it with addition. When you add, you're putting things together, so it doesn't matter what order you put them together as long as everything's accounted for. Multiplying is different because even with whole numbers, 23 times 46 means that every digit in 46 is going to multiply every digit in 23. You wouldn't just do 20 times 40 and 3 times 6. But when you get to this, that's what they do. They do 2 times 3 is 6, and a half times 3/4, and it's never complete. So the strategy that we will get to with multiplying mixed numbers is to put everything in the form of an improper fraction and then multiply. Just because that keeps them from making as many mistakes. If you look at it as an area model, which explains it, but I think it's harder for fractions because you're still going to end up with different denominators. So they have to go from this to finding common denominators and adding, and it's a little too much. But if they can just make 2 1/2 into 5 halves, and 3 3/4 into 15/4, then they can multiply. So that simplifies it a little bit. That's that. That's what we'll be working on for like the next 4 days or so, and then I'll have a small test on mixed numbers, and then we'll start division. So that's what we're going to do with you guys going somewhere else. So you can't see it, because I don't want to give away the secrets yet. It's going to be fun. Do you have something you can work on?
I got my book.
Okay, cool. Nice. All right, so let me show you how we're going to start. Oh, I forgot to show you. This was little projects that the kids did in groups. They were given a problem when we first started multiplying. And again, I didn't tell them they were multiplying, but they actually had, I said, if you were talking to somebody who didn't know anything about fractions, how would you explain it best? And they drew some really cute pictures. This was taking cough medicine. And when they got 35/6, they actually put it into 6/6 and counted out the holes. This one was a little bit more to read. Different ways that they saw 2/3 of 6 was on here too. The one that, and I've had a contest with this, the teachers have actually voted on the one that was the clearest, and the two winners are these two. Very neat. This one was 6 apples, each weigh 2/3 of a kilogram, so they did 6 2/3. They got 12/3. They drew their apples labeled, and then they put the 12/3 into groups of 3 that showed it was 4 holes. This one was really pretty clear. This one was running on a track that's 3/10 of a mile long and going 5 times, and they actually colorized all the laps and took the 3/10 and put it into a model of tenths. And when they got to the 10th tenth, they went to the next one and they showed it was 1.5. This one was really clever, I thought. But I was really especially pleased with this one. And I loved this because this was done by some students where they really collaborated. One student knew the answer but couldn't explain it, and the other 2 students thought up the number line. This one was more complicated. They had 5 hours. They traveled to Asheville, but they got a flat tire at 3/10 of the way, so how many hours was that? So they used a number line, and they realized that tenths would be half as big as 5 parts, and so they marked tenths on the bottom, fifths on the top, and got the answer of 1.5 hours. So this was all them. I just gave them the problem and said, solve it. And they were able to spend some time independently thinking about it and then collaborating and then producing a final copy. And then we hung them up around the room and the kids voted to see which ones they thought were the clearest. And then the teachers voted, so that was kind of fun. All right, division. What time? Okay, here we go. First day of division. It's going to be a fun day. This is when we get the Play-Doh out every year. And so that makes it fun for the students. So I start out by just telling them how we're going to represent things. And I go back to this chart. This chart has been part of our classroom since the 2nd week of school. And it talks about the 3 ways you can think about division. Even though you get the same answer with each of these 3 ways, it's a different way of thinking about it. The first way, if you have a total, and you know the total is always the dividend that you start with that you're going to break apart. The divisor, the second number in the equation, is how many groups you're going to make from this total. If you know the number of groups, what you're trying to find out, the quotient, is how many things are in each group. Then you swap it, and you'll notice it's colorized. You still have a total. Now you know how many are in each group, but you're trying to find out how many groups you can make of that size. And then the last one is thinking of it as the inverse of multiplication. You have a total that's a product of some problem. You know one of the factors, you're looking for the other factor, and that kind of lets them know that finding a quotient is saying what times this is going to equal this. And we talk about this all year long, and we'll talk about it again before we start fractions to remind them what division is. So here we go. What they'll do, each partner group will get a little laminated division chart, and it has the division box where the dividend goes here. The divisor tells them how to divide it. And instead of having the answer on top, I give them these cards, and I say each of these cards represents one group. So you can use these to group things on, and you put out as many as you need, so they get stacks of groups. And so we start out by saying, okay, I have a dividend of 6. So I want you to take your Play-Doh and make 6 little bunches of Play-Doh. Okay. This smells so good. I love Play-Doh. And the reason I use Play-Doh is because it's easy to divide, and it's easy to kind of put back together so that we can use with the same kind of manipulative, and it's just really fun for the kids. Sometimes I let them play for like the first 3 minutes, you know, get the Play-Doh out and do whatever you want to with it, and then they clean up, and then we start getting serious, so they get the playfulness out. But here's 6. Okay, so your dividend is 6, so there it is, that's what we're going to share. Okay. And so I start out with, okay, the divisor is 2, and that means you have 2 groups. And they're like, oh, okay, 2 groups. Boom. And they can start sorting them out however they want to, but they need equal groups. So there they are. They go, oh, the answer's 3. 6 divided by 2 is 3. And they already know that, but it's really visual this way. So then we go back, okay, put them back in your dividend. And then I'll say, okay, now the divisor is 1. You get 1 group. Oh, well, shoot. 6 divided by 1 is 6. So that's pretty fast. And we're just working through that. And then I'll say, and let me back up, because I haven't done this in a while, so let me think about which way I do it first. We go through some sample problems, and they're usually about Duke and Carolina basketball, so I might have to change it because the game's over. But we relate different problems to the different kinds of situations based on what's happening in the problem. And usually, depending on what kind of numbers you work with, one of those is easier to figure out than the other. So this, I think I actually start with how many are in a group, this one. I start with this situation. I did this with you for a second ago, but this is how we start. So I'll say, okay, you can put, the divisor is 2, you can put 2 in each group. That is how we do it. So they do 2 in each group, and they see that they have to pull out 3 groups. Same answer, 6 divided by 2 is 3, but it's a different way of thinking about it, as you can see. Okay, and then if there's 3 in each group, they would do, oh, it's 2 groups. Okay, so 6 divided by 3 is 2, and here's where it gets fun. 6 divided by 1/2. So we start with that, and that means you get 1/2 in each group. And really, this one is easy for them because they've got the 6 parts here, and they've got Play-Doh, so they go 1/2 in each group, and they start tearing their Play-Doh in half. And it's really interesting because as they're doing it, they're going, wait a minute, this is a lot of groups. And they start to see that division can result in a quotient that's bigger. Now, they should know this because we did it with decimals, and we did it with cups of rice. But still, to have them do it again with fractions is always eye-opening. And once they start doing it, most of the students will go, it's going to be 12. It's going to be 12. And they get it out. I make them go follow through, and they get there, and they're like, and I say, okay, count them, and they get 12. So here's how the tables are looking at that point, and they're having a lot of fun with it. And then I could actually do 1/3 where they split it into thirds. And usually somewhere along the way, we're doing all this on paper, we're writing down our answers. Some student will say, this is like multiplying. And we'll talk about that for a little bit, and talk about why that is, and then we go to this. Here's the fun part. So let me put my 6 back together. Okay, there we go. All right. So they're really feeling really confident now. They've worked through different divisors, different fractional divisors, 1/3, 1/4, and they're like, yes, we know. And they kind of know what the answer is going to be, but then I'll go, let's think of a different way of thinking of division. Now we're going to go to this one. And so I'll do, how many groups, which I did with you just a second ago. But now I'll go, okay, the divisor is 1/2, and that's how many groups you get. And everything just goes dead quiet because they pick up a group and then they go. They cannot figure out what to do, and they start doing things that are a little bit wrong, and then they start looking at each other like, this doesn't make sense. And so I go back and remind them. I say, if you know how many groups you have, you're trying to find out how much would be in one whole group. And so if they're still stuck, I'll come on and say, how do you show me half a group? And at that point, they start to go, well, if this is a group, that's half of a group. And that's your divisor, so everything goes in that. And that's when you go, okay, how much would a whole group be? If half a group is 6, the whole group is 12. That is so much harder to think about, but it's so fun to watch them work through it. But it shows them that no matter what the situation, your answer is going to be the same. So if it's confusing to think about it one way, you just understand it in the other way. By the end of the first day, a lot of the class is already figuring out that dividing by 1/2 is multiplying by 2. Dividing by 1/3 is multiplying by 3. And in 5th grade, that is the kind of division we do. It's whole number and unit fraction. So really, they've kind of gotten there on the first day, but then we do a lot of additional work on why that is, drawing models that if, and they are usually able to say, well, if you divide by 1/2, you need 2 times as many parts to make that 1 part. So it is multiplying by 2. And we relate it back at the very beginning of the year when we did place value. We talked about how moving to the right on the place value chart was dividing by 10. but it's also getting 1/10 of something. And 1/10 of is multiplying. So we relate it back to decimals. 1/10 of something is dividing by 10. And this sets them up for later understanding a little bit about reciprocals. We do not officially do that in 5th grade. I will, depending how we go, I will talk a little bit about that. And one thing that's kind of fun is we do not do this in 5th grade, but I can show it to a few students. 1/2 divided by 2/3. And I'll say, remember when we did whole number division? Oops. Can you do that with fractions? And they're like, no, maybe, kind of. So yes, that's a number. This is a number just like this is a number. So this equals 1/2 divided by 2/3. That's really hard to understand. So how can we get it to where we have a 1 on the bottom so that we can understand the value of this? And by that point in the year, a lot of students will say, multiply this times 3/2, because that will give you 6/6, and you have 1 on the bottom. And how do we proportionally do this? You multiply this by 3/2. So if you'll notice, we are multiplying by the reciprocal, and you get 3/4 over 1, which equals 3/4. So this is sort of as close as I get to teaching reciprocal in 5th grade, but because I want them to kind of understand what's happening here. There are a lot of word problems you can give students to try to lead them to that understanding. What I don't want is for them to get to middle school and learn the procedure and not understand it. And I have had students in 5th grade who have learned the procedure, but they do it backwards, and that's why it's really, teaching procedure first is not always the best way. Because I've had students that come in and go, oh yeah, you flip it, and then you multiply, and they do all this weird stuff, but they don't understand what they're doing, and they don't know what to flip, and they don't. So anyway, that's why I think that Common Core does it in a very limited version in 5th grade so that they can really understand what's going on by doing hands-on things that they can manipulate and visuals that they can see, and understanding that dividing by a fraction is multiplying by its inverse. So we'll see. But that should come sometime next week. And then the week after that is our Case 21, our quarterly, which is going to expect them to know all of this. And I will say, I feel like the students right now are a little bit overwhelmed that there's so much that they've learned. This is really heavy. Since mid-January, after the snow was really about when we started, and it has been like fast ever since then, something new every day. And we're trying to find time to practice, but it starts to jumble in their brains about right now. So I think after we get through multiplication, I'll probably spend a day of just practicing different kinds of problems again, and before we start division. And usually once they learn it, they understand that division is maybe the easiest thing in 5th grade. And I hate to do procedure or tricks, call it tricks, but they start to understand that the answer to this has to be a relationship there. It's either going to be 42 or 1/42. That's the only 2 possible answers to that question. And then they have to start thinking about it. If you take a fraction and you break it into parts, you're going to get a smaller fraction, so it has to be this. And then they start to notice relationships. Oh, when you start with a fraction, you end with a fraction. So there's a lot of kind of tricks they start learning about it. And I don't want that to just be a trick they learn because it applies to 5th grade. So we try to talk about why it works. But I do like that they're seeing a relationship between these numbers. And that's all. Do you have any questions or suggestions or things you want to slap me about? I don't know. How do you feel about me not sending homework? How do you feel about it? Is it? I would love to know from parents. I haven't had any parents write and say, please send homework. I've had a couple of kids ask for homework. And I'll be honest with you, I had a student the other day who said, I would like some homework. And I said, okay. And I said, write down a fraction. And he wrote it down. I said, write down another fraction. Can you add those 2 together? And he was like, yeah, but I want you to make it. So it really is desire and motivation to do it. and I'm glad to help any student, but sometimes I see that it's just they want me to do the work for them, so, that's kind of how we stand on homework right now. And I know that the school as a whole is trying to cut back on homework. We know you have lives and families, and they're gonna get hit hard with it in middle school. So we've always thought we need to develop that habit, but I think it develops when they get there and they start seeing the consequences of not doing it. We have no consequences for not doing homework in elementary school because it's not graded. And so we just cross our fingers and hope. You know, we can, it's a lot of record keeping to keep up with, and calling parents and all that. So if you have consequences, it's just really, really time consuming. In middle school, it'll just be a grade in the grade book. And they'll start to understand that this really does make or break me when I get there. So I've had so many discussions about that with them, and it didn't seem to affect the turn-in of homework. So I finally just kind of hands up, white flag. We'll just see how it goes without the homework. So that's where I stand on that right now. Anyway, thank you.
Thank you.